Welcome to lesson 21, problem number 2, where the entire page of problems is a set of light bulb problems. So be ready. These are all challenging, but you can do it. We're going to follow our steps. The first part of factoring, the first step is always to look for the greatest common factor, and then we're going to look at the number of terms and then see if we can factor again. So let's get rolling. All right, problem 2a. I'm going to start by taking out the greatest common factor of 4. So I have 4 times the quantity x to the fourth minus 2x squared plus 1 minus 25y squared. Okay, now I've been doing this a long time, so it's easy for me to say, oh, look, it's a perfect square trinomial. But it is because we know the square root of the first and the last term, and if we take those square roots, multiply them together, and then multiply by 2, we get the middle term. So we know it's a perfect square trinomial. So I'm going to leave that 4. This is that 4. I'm just going to keep writing that every time. But this quantity now can be written as x squared minus 1, the quantity squared. All 3 of those terms factor into this parentheses right here. And if you're not sure about that, feel free to look back at the perfect square trinomial problems, but that is how we factor perfect square trinomials. Or you could think of it as an AM problem if you prefer, and just know that it's x squared at the beginning instead of x because it's an x to the fourth that we have to get when we multiply. All right, so now I'm going to underline this just so you can see I still have the minus 25y squared. I'm keeping that in blue so it's really clear. Now, the great news is we are actually almost done because this 4 is going to repeat it one more time. So that keeps getting written down. And now it's the difference of 2 squares because x squared minus 1 to the second is a perfect square. 25y squared, oops, sorry about that, 25y squared is also a perfect square. So what we can do is we can simply say x squared minus 1 minus 5y, and then we have x squared minus 1 plus 5y. And we're done. If you wanted to, you could certainly see if anything would factor again, but we know we have x's and y's, and there's no way it's going to factor again. So we are done. Okay, B. So for problem B, we're going to again look for greatest common factor, which if you see it in this case, it's going to be y. So it's y times the quantity 20x squared minus x minus 1. Okay, so from there, it looks to me like there is not a perfect square trinomial because this is not a perfect square. And we can't just do an AM, and I hope you know why, but the reason we can't do an add to this, multiply to that, is because there is this 20 in front of the x squared. So we have to do the splitting the middle term, or at some point you might do guess and check, but for right now, the way we're teaching it is splitting the middle term. So we take a times c, which is negative 20, 20 times negative 1. So we take negative 20 and we have to figure out what 2 numbers multiply to negative 20 and add to b. B in this case is negative 1. So it's negative 5 and positive 4. So now what we have is y. I'm going to keep bringing down that y. In fact, let's leave that y to the very end. I don't want it to confuse you with the fact that what we're doing right now is factoring what I'm underlining in green. So we're going to now say 20x squared. Let's do the minus 5x first, but it makes no difference. Then I'll do the plus 4x and then the minus 1. The reason it's called splitting the middle term is we split that negative x into negative 5x plus 4x. Okay, we group 2 and 2 and take out the greatest common factor. The greatest common factor with these first 2 terms is 5x. So we have 4x minus 1. And then for here, there is no greatest common factor other than 1, so I'm going to put a plus 1 and 4x minus 1. The great news now is we must have done it right because these 2 parentheses match. So our final answer, we can't forget this y. That y is still there. So I'm going to just write it right here. It's going to be y times the greatest common factor of 4x minus 1. And what's left over is the 5x plus 1. And we're done. All right, let's go to C. Okay, so there will be a little bit more room. Sorry about that one taking up so much space, but For this one, it's already the difference of two squares. There's no GCF. Let's go. Difference of two squares. So the first parentheses is going to simply be x squared minus 5x minus 6. And the other parentheses is going to be x squared minus 5x plus 6. Now, remember, we always look to see if we can factor again. And now we have trinomials, and the leading coefficient is 1 in both of those. So it's an AM, and we can see if it works. AM and AM is, if it does factor, we have to have that AM situation. So I'm going to look at the first parentheses. Two numbers that multiply to give us -6 and add up to -5. Hey, we've got it. Oh, no, I jumped to the answer. -3 and -2. That's what everyone wants to say. But that multiplies to a +6, not a -6. Honestly, I think this is in lesson 33 or something very similar as a common error. But I purposely did that. You might not believe I purposely did it, but I did because everyone does that. Okay, what we need is -6 and +1. -6 times 1 multiplies to -6 and adds up to -5. So we can now write this as x minus 6, x plus 1. And now let's see what this becomes. Here we go. -2 and -3 multiplies to +6, adds to -5, x minus 2 and x minus 3, and we're done. This whole four-factor quantity is our factored form. Okay, let's go to D. D is challenging. I'm going to change our color so you can see it in there. The hint with this one is it's really like a problem that I would call an AM problem in a way, but it's in a big, big disguise. So here's what we have to do. We have to start, and I know this is challenging. We're going to use our exponent rules because I know that 3x somehow has to affect this first term. So watch what we're going to do. Okay, so we're going to rewrite 9 to the x as 3 squared because that's 9. And then I could write that as 3 to the 2x. Now think about that. 9 to the x is the same as 3 squared, or 9 is the same as 3 squared. So 9 to the x is the same as 3 to the 2x. If you're not sure, think of it this way. Think of it as 3 squared. Okay, so that would be 3 squared to the x, and then this 2 and this x multiply each other, so you get 3 to the 2x. Okay, so then you'll probably recognize if you are kind of wondering why I know to do that, but look at this. Do you see how there's also a 3 to the x right here? So that 3 to the 2x becomes what we put in the first parentheses. And honestly, it's now an AM problem. Because if we put 3 to the x here and 3 to the x here, our first term would be 3. Oops, that's not just 3x, that's 3 to the x. But our first term would be 3 to the x plus x, or 3 to the 2x. So that checks. Now watch this. If we could think of the two numbers that multiply to give us 12 and add to 8, like -6 and -2, they multiply to +12 and add up to -8. Watch what happens. If we were to multiply this out, we would have 3 to the 2x. Then we'd have -2 times 3 to the x, and then we'd have -6 times 3 to the x, which gives us our -8 times 3 to the x. And -6 times -2 gives us +12. So all of that work results in this answer, which I'm going to circle in red. It was not as bad as it looked, but it's really tricky, I will say. Okay, you ready for more light bulb problems? Here we go. Okay, for 2E, basically this is very similar to the splitting the middle term problems, but the issue with this one is when we split the middle term here, what we're really doing is we're really thinking of it as, instead of like x squared, we have h to the 8th, but it's still a splitting the middle term problem. So if you would like, we could think of it this way at first, if you want to. Think of it as, if it was 3x squared minus 5x plus 2, we would know to come up with the two numbers that multiply to 6. Because 3 times 2 is 6, and that would add to -5. So it's very similar to the other one we did. We're going to do -2 and -3. So once we do that, it's going to be very similar to the other problems that we've done with splitting the middle term. It's just much more complicated because of the h to the 8th, h to the 4th, and so forth. But let me work through it now with you, because now that we can see that those two numbers, -2 and -3, add up to a times c, or sorry, multiply to a times c and add up to -5, we are really close to being able to do this problem. So I'm going to rewrite this as 3h to the 8th, notice I'm splitting the middle term, minus 2h to the 4th, minus 3h to the 4th, plus 2. Okay, I haven't changed the expression's value. I've just split that middle term. Okay, now I'm going to take the first two terms and take out the GCF of h to the 4th, and I'm left with 3h to the 4th, sorry, not to the -4, 3h to the 4th minus 2. And then here I can just take out a -1, and I again have 3h to the 4th minus 2. Okay, I'm going to get rid of the part where we found the two numbers that we should split the middle term into, just to give us a little more space. Okay, so now we have a GCF, and the GCF is 3h to the 4th minus 2. And what we're left with over here is h to the 4th minus 1. Okay, so we have a little ways more to go. So from there, what we have to do is we have to say, all right, we have, this cannot factor again. It's two terms, but it's not the difference of two squares. This is the difference of two squares. So I'm going to kind of go up here for a minute and kind of make a little space here. So what we're going to do is we're going to rewrite the 3h to the 4th minus 2. That is not going to change. It can't factor again. The h to the 4th minus 1, I'm going to rewrite as h squared minus 1, and h squared plus 1. Okay. Good news is this factors again, good or bad, depending on how you look at things. Okay. So our final answer is going to be 3h to the 4th minus 2. H squared minus 1 can factor again as h minus 1 and h plus 1. And then at the very end, we have, I'm just going to get rid of this little line to give us a tiny bit more space now. And let's just do this. And then we still have the h squared plus 1. And I guarantee you that if you were to multiply those four parentheses out, you would get right back to 3h to the 8th minus 5h to the 4th plus 2. Kind of tricky, huh? Okay, I know these are all tricky. All right, the good news is F is not going to take nearly as much space. So hopefully you're starting to recognize that a lot of these are either AM problems or splitting the middle term. They're just in a big, like, disguised form. So I'm going to go to F, and what we're going to say now is I really want you to look at this as just an AM problem. It's a trinomial with a leading coefficient of 1. And so we just have to add to -4, multiply to +3. So that would be a -3 and a -1. And then in this first position, we can just put the square root of k to the 4x. If that first term was x squared, we'd put x in each parentheses. So we're going to, just like here, just like there, we're going to take the square root of k to the 4x and make it k to the 2x and k to the 2x. Look at that. So if you want to try just doing a little mental math, that gives you k to the 4x minus k to the 2x minus 3k to the 2x plus 3. If you multiply it out, you will see you'll get back to the original. But we're not done yet, because k to the 2x, that can factor one more time, because this is the difference of two squares. So the first parentheses, k to the 2x minus 3, stays. But this parentheses can be written as k to the x minus 1 and k to the x plus 1, because it's the difference of two squares. Now we're done. Crazy problems, I know. Okay, if you can do these, boy, you're ready for some more advanced math. Okay, let's go to G. So for 2G, what we're going to do is it's really an AM problem again. So what we're going to do is we're going to, in this case, use the fact that the middle term is x to the 1/2 as a little hint. It tells me that the first term in each parentheses should be x to the 1/2, because I know that then that will give me x to the first for the first term, which is exactly what we want. And now it's just an AM plus 5 plus 1 because it's adding to 6 and multiplying to 5. And just like that, we're done. Okay, that one was not so bad. All right, let's go to H. And for H, what we have, oh boy, it looks like an AM problem just in disguise again. So we have to think of the two numbers that multiply to 40 and add up to -14. So let's go with -10 and -4. Those two numbers multiply to 40, add up to -14. So this time we take the square root of the first. So we're going to say x squared minus 3x. I'm going to leave it in parentheses for the first part just to kind of show you. Minus 10. And then the second parentheses is going to be x. I'm going to put that in parentheses again. Let's just do a double parentheses. X squared minus 3x. And I think we can get rid of these two numbers now. You know that they're -10 and -4. And then I'm going to do that minus 4. And this is just to make sure you see why this really works. If you were to multiply this out, this quantity and this quantity that I'm underlining, if you were to multiply them together, it would give you this. Okay, I'm going to change the colors. This would give us -4 and -10 of those quantities. There's the -14 of that. And then, of course, -10 times -4 gives me 40. So I'm hoping you can see by the color coding that yes, if we were to multiply this out, this would really work. But we're not done yet. So I'm going to take away all those lines just to make it a little bit neater for you to see now, but hopefully you now see how everything worked there. And what we're going to do now is we are going to look at this first quantity, which I'm going to now underline in green. And believe it or not, it factors again because it's now another AM problem. The two numbers that add to -3 and multiply to -10 are going to be -5 and +2. So just like that, we can factor that one again. And not only that, but guess what? This one factors again too. So now we have x minus 4, x plus 1, and just like that, we have factored this entire page. So way to go, hanging in there. Send me questions. Great job trying all these light bulb problems. If you can do these challenges, it really stretches your brain. So keep working hard. Great job.